There are two laws we're going to be talking about for laws of thermodynamics, basically how energy and heat operate and how they will always operate, which will help us predict reactions and predict how matter and energy move around in a system. But to do that, we need to talk about how heat transfers. And there's three main ways heat transfers. So there's conduction, convection, and radiation. So conduction is this idea of when a substance transfers heat to another substance. So think about like a metal, like maybe you're eating something hot, like a bowl of soup. It's really hot. You put the spoon in, and in a short amount of time, the spoon is also very hot, right? Because spoons, metal, are really good thermal conductors, meaning the heat from the system, in this case the soup, transfers quickly to the metal spoon. Okay. Convection is when a warm substance changes location. Okay, such as warm air rising. And we can also think about this. Let's just draw a little pan. So maybe you're making a fire or you're cooking something. All right, and you have the water in here. So convection, we've talked about convection before, how basically it's due to density and thermal energy. So the water in the bottom of the pan, right, this is heating up faster, right, because it's closer to the flame. Warmer molecules are less dense than colder molecules, meaning the warm molecules, less dense things go on top, denser objects go to the bottom. So the less dense objects are going to go to the top, and then the colder objects, in this case the less heated up water molecules, go to the bottom. And this creates a pattern or a cycle of molecules moving around based off of their thermal energy. And so this is a good way heat moves. And the last one is radiation. So this is when electromagnetic waves carry energy from an energy source, such as the sun. All right, so if we have the sun, it has radiation that we can't see that's also going to Earth and being absorbed by molecules, specifically electrons. So sometimes those electrons get absorbed and then that energy goes up. So these three ideas of heat transfers lends itself to this idea of hot and cold that we experience on a daily basis. So sometimes you'll feel hot when you touch an object and sometimes you feel cold. What exactly are we talking about here? Well, it's important to know hot and cold are actually just kind of relative terms. So say you pick up an ice cube, right? That's going to feel cold, right? Something that's kind of important to know is that there is no such thing as cold transfer. It's not like the ice is putting cold molecules at you. Okay, that's not the way to think about it. What we do want to think about is a transfer of heat, not cold. That's not how many fingers there are in a hand. Oh well. Instead of the ice cube coming out towards you and like attacking you with coldness, you're actually losing heat. So the heat in your hand is actually being absorbed by the ice cube. So you're losing energy there. You're losing thermal energy. Okay. Conversely, if you pick up a hot spoon, right, say it's Let's make it red. So what's happening there is you feel hot, or thermal energy. You feel it really hot. It might burn your hand because that energy, in this case, hot things, that's coming out and attacking you. It's kind of like taking whatever it can touch and just like overwhelming it with thermal energy. Okay, so when something is cold, that's energy you are losing. And hot, when you feel hot, that's when energy from the system is being absorbed. Right, it's too much energy to absorb. And this will keep happening. Let's say, for example, right, we have something that's hot on this side and cold on this side, and we lift up this divider. Maybe you have hot water on the left and cold water on the right. So when we move the divider, these two things will continue to exchange and transfer heat until we get to something called thermal equilibrium. Okay, heat is going to continue to transfer, and it's always moving until basically it's dispersed. So also another big idea that these two things kind of illustrate is that heat transfer always comes from a hotter substance to a colder one. All right, so we talked about that hot spoon, that energy is coming out from the spoon and to your hand. And when you're holding an ice cube, the energy in your hand is leaving your hand and being absorbed by the ice cube.